Let's start with what a sequence is, right? So a sequence is basically just an ordered list of numbers. It's just a list of numbers, right? And just like in matrices, in a sequence, each number is called a term. All right, so we have two types of sequences. There is a finite sequence, which contains a finite number of terms, right? Like this here is a finite sequence, 1, 3, 5, 7, 9. There are 5 numbers in there. That's a finite sequence. So if there is a specific number of terms in a sequence, it's finite. It could be 5 terms. It could be 3,764 terms. Still, it's finite. An infinite sequence has an infinite number of terms. So basically, it never ends. It just keeps going and going forever. So for example, this one here, 2, 4, 6, 8, ... Those are, all the odd numbers going up to infinity. All right. A quick notation review, or lesson rather. All right. Each term in a sequence is labeled by its subscript. And the subscript tells you which position in the row of, numbers it is. So the first number is A1. The second number is A2. The third number is A3, and so on. So if I have, A9, that's the 9th number. Sometimes it starts at 0. So it's A0, A1, A2, A3. So like the 6th term will be A sub 5, right? Now, if I'm talking about some random sample in the sequence, right, I say A sub n. So that's like saying John Doe, right? Or, like a random student, like Bob Smith, okay? That's what that is. It's just an. Now we have an, right? So suppose we're talking about this an. The term that comes right before it is A sub n minus 1, right? And then the term that comes right after it is A sub n plus 1. So what does that mean? Like suppose I have, I'm talking about A sub 6. The one right before it is A6 minus 1, A to the A5. Then the one right after it is A7. Do you see what that means? Okay. Now, so for example, if I have a list, here is my an, right? So the one before it is an minus 1, n minus 2, and then after it, it's n plus 1, n plus 2, etc. We'll use that notation a lot more later on. All right, so a sequence can have numbers that are, that have like very recognizable patterns, like the one, with all the odd numbers, 1, 3, 5, 7. Or it might not be so obvious, but often the terms in a sequence can be described by a formula. So, and that's called an explicit formula. Okay? An explicit formula gives you a way to find any term in the sequence. So take a look at this one. It says to find A4, A sub 4, if this is an. So all I do is plug it in. So I say A to the A4 is 3 times 4 plus 1 over 2. So that's 13 over 2. Okay? So like with that, you could find like all the terms in the sequence. A1, A2, A3, A11, A51. Okay? All right, here, we used to do this in geometry. You've done it before. Find the next term, right? One way you could do it is figure out, how do you go from one to the other? It seems like you're subtracting 4, subtracting 4, subtracting 4. So then it'll be negative 13, 17, and then up to negative 25. Okay, so B, I add 3 to go from 2 to 5, and then how about here? Right. Right. So at 7 I get 24, and then sorry, 26, add 9. And then 65, right? Here, the next 4 terms, right? So we're given the formula, so we need A1, and that's just gonna be 1 plus 1, 2. Right? We're plugging 1 into n. A2, what'll it be?
Did you start with A0?
We normally go with 1. 9. It really, yeah. And then A3, 28. And then A4, 65, right. Okay?
Isn't it not? I thought it should like the next 4 terms, right? You know what I'm saying? Like, n could be like 20.
Right, but if you're just starting the sequence, and if you're not given any like initial information, just start with 1. Okay, so like it says, you know, start with whatever. Okay, so recursively defined sequences. A recursive relationship happens when you have a few initial values, and then after a certain point, each new term you have to find uses the terms that came before it. Okay? So you have a few initial values, and then each term is defined using the first few terms. So for example, take a look at this one. You're given A1 equals 1. And then after that, every element you have to find. How do you find it? It's an minus 1 plus 2. So what's an minus 1? What's that term when you have an? It's right, it's the term right before. So term right before plus 2. So if I have to find the 6th term, what do? Take the one right before and what? Add 2 to it. So whatever term I have to find, I have to take the term right before and add 2. Like, so you see how it's recursive? If you want to go forward, use the one that came right before it, add 2. Use the one that came right before it, add 2. Okay? So it's like links in a chain. So take a look at this one. It says find the 4th term of a recursively defined sequence. Here, A1 is equal to 3. So this one is just given to you. And then an, each respective term, right? What is it? It's 3 times an minus 1. That's the one that comes right before. So this is the preceding term. Right? And then minus n plus 2. So let's just do, okay, we need A4. Before that, though, we need to find A2 and A3, right? So what about A2? A2 is going to be 3 times what?
1.
Not 1,
2.
not 2,
Oh, 5.
not 5.
Oh.
3,
Oh,
right?
3, yeah.
Because look, it's 3 times the term that came right before the one I'm finding now. So that's a 3. Okay? Minus what's n? What's n here? 2 plus 2. So that's going to be a 9. Okay? All right. A3 is 3 times what number? 9 minus 3 plus 2. So that's 27 minus 1, 26.
Why do we need A of 3?
Well, because we need A of 4. It says to find the 4th term, which is A sub 4. But how do you find A sub 4? It's 3 times A3, blah, blah, blah. So it's 3 times what?
26 minus 4.
And how much is that? How much? 3 times 20, that's 60, 86, 88. I'm sorry, 78. minus 2 is 76, right?
Really quickly, why is this?
Very famous recursive function or a recursive sequence is the Fibonacci sequence. Have you heard that before? So Fibonacci sequence, here is how it's defined. The first term is 0, the second term is 1, every other term, so if I wanted to find A3, how would I do it? It's what plus what?
1 plus.
Well, yeah, it's A2 plus A1, right? Okay, if I wanted to find A7, what is it? A6 plus A5. So each term is the sum of the
one before and the one before.
right, the two terms that come right before it, right? So again, if I want to, right? So if I want to find the fourth term, well, first I need the third term. A3 is 0 plus 1. A4 is what? 1 plus 1, which is 2. It's easier if you actually write it as a sequence. So 0, 1, and then it's 1, and then it's 2. So the next term would be 3, and then 5, right? So if you continue, it'd be 3, and then 5, and then 8, and then 13, and so on, right? So each term is the sum of the two terms that come right before it. Okay, so far we're literally just laying the groundwork, okay? Convergent and divergent sequences. All right, so just like we learned way back when we were doing limits, that functions at infinity, a function might approach a specific value or it might not. Sequences can do the same. After, as you go towards a sub infinity, the numbers might be approaching a specific value or they might not be. So if the terms of a sequence approach a unique number, then we say the sequence has a limit, and we say the sequence will converge, or the sequence converges. If you see that as you progress to the terms, infinitely large terms, or as n approaches infinity, right? If you see that the numbers are not approaching a specific value, then it doesn't converge. And that we say it diverges. So take a look at this one here. So this is the formula for each n. So a sub 1 would be 1 plus 1 over 2, which is 1, right? Right there. A sub 2 would be 3 over, 8? So there. And then as you keep putting in your values, a sub 20 is here, a sub 25 is here. So you can clearly see that a sub 100, a sub 5,000, these numbers are going to approach 0, right? So that's an example that converges, and we say it's convergent, right? So the noun and the verb. This one, does it look like as n approaches infinity, these numbers are reaching a specific value? No, so this is divergent. All right, so let's do a couple of examples here. We want to determine, and sometimes you can see it right off the bat. Sometimes you need several for you to be able to see it. So let's take a look at this one. All right, so a sub 1 is going to be negative 4,000 times negative 1 over 4 to the 1. Well, that's just positive 1,000, right? Okay, we do this the same way for a sub 2, and we get negative 4,000, negative 1 over 4 squared. Now, if you square that negative 1/4, it's going to be positive, so the answer is going to be negative 250. And moving down, A3 is going to be 62.5. A4, negative 15.
Would we have a calculator?
Yeah, for these you would. A5, 3.9. A6 is negative 0.97. So let's just graph this. When let's see. When n is 1, we're at 1,000, and then when n is 2, we're at negative 250. Oh, this was 1, not 0. When n is 2, we're at negative 250, and then 62.5, and then negative 15, and then 3.9, and then negative 0.97. So what do you think? Divergent or convergent? I would say it's convergent. Because as this progresses, what value? They're both approaching from 0. Yes, it's alternating. Okay? So this is an important characteristic. Many sequences alternate in sign. So much to tell you about this. So we see that it's alternating in sign, but eventually, look, they're getting closer and closer to 0 from the positive and negative side. So yes, this is going to converge to 0.
Do you do A of 0?
We could, if we did A of 0, what would it be? Negative 4,000, right? Now, could we have known from the very beginning that this was going to alternate signs like this?
Oh, yeah,
Because of the what?
Because they're both negative.
Well, look at this.
that exponent now.
You have a negative number raised to an exponent. And if n is even, right, then you're going to have, right, then if n is even, the stuff in the circle here will be positive, so the whole thing will be negative, right? So if n is even, for example, here, right, even n will be negative. If n is odd, right, if n is odd, that's going to be negative times negative positive. So n is odd, n is 1, n is 3, n is 5. Those are all positives, right? So when we're dealing with sequences then, anytime you see like a negative raised to the n power, it's going to alternate signs because n is going to alternate between odd and even. All right, let's do the next one then. We have negative 2 to the n over negative 2. And you generate your terms in the same way. And people ask me every single time, how do you know how many terms to do? You have to do at least 4. And then go up to however many it takes for you to figure it out. Okay? So in this case, I'm actually going to give you a couple more. So A1 is, right, negative 2 to the 1 over 2. So that's negative 1. All right. Is this going to alternate signs?
Yeah.
Yeah. So A2 is going to be 2. A3, negative 4. A4, positive 8. What's it doing? How much? How much larger? Double. And what's happening to the sign? It changes sign. So I bet this is going to be negative 16. And I bet this is going to be positive 32. And then negative 64. And then what? Right? So take a look. When n is 1, we're at minus 1. When n is 2, we're at 2. Then we're at minus 4. And 8. And then we're at negative 16, which is here. And then we're at 32. And then we're at negative 64 here. And then what? 128. So all the way up there. So what do you think? Converging, diverging? Converging. Oh, wait, what? Is it converging? It's diverging. Because, okay, so what's it doing? It's moving away and you don't even know where it's going to end. Okay, so as you reach n equals infinity, a sub infinity, first of all, what value is it going to have? Like the absolute value of it is going to be like a huge number, right? Okay, a sub infinity. is it going to be a positive large number or a negative large number? How do you know? Do you know? Where is infinity? We don't know. We don't know where infinity is. So I don't know if it's like a very large number on the positive side or on the negative side. This is definitely convergent. Divergent, sorry.
Oh, I meant to say that.
Yeah.
Let's say divergent.
All right, so here, A1 is 0.1. A2, 0.0067. We know this because we put all these in the calculator and we generated these numbers right now, right? Yes, question?
I'm just kind of still why it's divergent.
Okay, because as you progress through your sequence, your terms, what's happening? It's moving, it's like the numbers are getting bigger and they're alternating sign, right? Okay, so if you go to infinity, right? Okay, so if you're at like a sub 100, you can figure out what that is because you could put 100 into here. But what about a sub 100? I mean a sub infinity. Do you know, do you even know what side of the x-axis it's going to be in? If it's going to be positive or negative? You don't know. So it's convergent if it absolutely, if it approaches a specific value. Is this approaching a specific value? No, because it keeps, oscillating back and forth. So we don't know. Okay? All right. Here, a sub 3 is 0.4 zeros and 6. And a4 is 0.4 zeros, 57. Right? So we could graph this. Like this is 0.1. 0.067 and so on. Okay, what's happening as n gets bigger? Smaller, smaller, and approaching what? 0. So this is convergent.
The number 2 would be like a lot further than that.
Huh?
The number 2 would be a lot further than that. 0, 0, 6.
Oh, yeah. It'll be here. Yeah. Correct. Again, this is very, very early on in the game. Right now, I'm just telling you, we're still at the point where you need to recognize if you see numbers, or if you see a plot, is it convergent or divergent? Later on, you're going to be able to do this without even graphing, without plugging in points. But right now, we're still understanding what is convergent, what is divergent. Yeah, it is a way. It's a way. We're going to do that later. All right, so suppose you take a sequence, okay? Suppose you take a sequence that has 5 numbers. Or you're at the beach one day and you happen to find a piece of paper that has a sequence on it of like 134 numbers, right? And then you tell yourself, oh my gosh, I'm just going to add up all these numbers. What you've done is you've converted that sequence into a series. So that's what a series is. A series is when you add up those numbers in a sequence. This word is important. It's an indicated sum. What does it mean that it's an indicated sum? It means if you have a sequence of, let's say, 500 numbers, you could take the sum of all of the 500, or you could take the sum of the first 20 or the first 5. So that's why it's an indicated sum. All right? A finite series is the indicated sum of all the terms of a finite sequence. An infinite series, an infinite series is actually the sum of an infinite sequence. How many numbers are in an infinite sequence? Infinity, right? An infinite number of numbers. Imagine adding all those up. So take a look here. This is a finite sequence, and if you add them up, that's a finite series, and you know exactly what value you get there. What about this one? Infinite sequence. This is an infinite series. So what would the sum of that be? Right. Okay? Okay, so how do you take the sum of the first n terms of a sequence? Well, of a series. So, first of all, the sum of the first n terms is called the nth partial sum, and it's denoted by S sub n, right? The sum of the first n terms, that's what that is, S sub n. So, for example, if I wanted to find the sum of the first 4 numbers, it would be S4, all right? To find it, very simple, you have to find all the terms up to A sub n, then you have to just add them up, okay? So let's do that here. The fifth partial sum of A sub n. So fifth partial sum, we're looking for S sub 5. So we're going to add up A1, A2, A3, A4, A5. Okay, what's A1 now? -2 and A2? 1 and A3 and A4 and A5, 22. We add up all of those numbers and we get, how much? 40. Yep, S of 5. I don't know why I said 4. Okay. Okay, so same thing here. S sub 4 is A1, A2, A3, A4. So what's A1 here?
3.
3, and then A2?
3 over 2.
3 over 2.
3 over 4.
2 over 3.
2 over 3.
Yeah,
Huh?
2 over 3. Because it's 6 over 9 divided that by 3.
Isn't it? No, it's 6 over 8.
I'm sorry, 6 over 8. 3 over 4.
Are we good now?
Yeah.
Right, so they're
Isn't the
powers of 2.
even isn't the that's 7? Yeah.
Right? And if we add up all of these, we get what? What's the decimal? What's the fraction value? It's 45 over how much?
45 over
8.
4.65.
Yeah.
Right. Okay. So let's talk about sigma notation. So we got 5.625 for that one. Let's talk about sigma notation. All right, I just said that, right, we used S for sum, right? Okay, so that's capital S in English, and this is lowercase s in English. Are we good? Okay. In Greek, the letter that makes the s sound is sigma, and this is lowercase sigma, and this is uppercase sigma, right? So that's just the Greek S, okay? So in fact, like, you know, Hollywood uses that for an E a lot of the time, right? And that's wrong. You know, like if they have like a Greek theme, you know, they use that as E's, like in their fonts.
Yeah.
It's an S, it's not an E. Okay. So sigma notation is just another way to say sum and add them all up. Okay. So look at this one here. You have this sequence A1, 2, 3, 4, right? And suppose you want to add up a certain number of these. Okay. What you do is you say, okay, sigma, right? So you're going to add, what are you adding? You're adding an, right? All right, now, and then, okay, so how many of these are we adding? Well, we're adding the ones that start from n equals 1 and go to n equals k. All right, so that's how I do it. So for example, if I wanted to start with Okay, so if I have A1, A2, A3, A4, sorry, if this is my sequence, right? And if I wanted to add up just these three, okay, what would I do? I would say, okay, add up all the numbers in this sequence, okay, all of the ANs, specifically the ones that fall into this range, from n equals 2 to 4. Okay? So, again, I'm telling it to add up the terms from a sub 2 to a sub 4. So that's 3 terms in total. All right, so here, let's find each of these sums. Okay? All right, so here we're adding up the numbers from, we're adding up A1 through A4. Okay? So what's A1? 0, right? Okay, so it's going to be 0 plus A2, which is 2, plus A3, which is 6, plus A4.
Wouldn't it never say that though? That could be S4.
Huh?
Wouldn't n never be 1? That could be S4.
That's another way of writing the same thing. Or I could have said find S4 if an is n squared minus n, huh? No, I don't know. Oh, it's you'll see that this is a much more efficient notation. Okay, so this is then 20. Yes.
Sorry, what was the notation you made about the?
I was just giving you like another version of it.
Is that so? All we need is the numerical value.
Right. Well, I need to see work. I need to know where it came from. Right. Okay. Right. But the you know, that's the answer, if you will. Okay. Okay. So take a look at this one though. Take a look at this one. We're adding up how many numbers from n equals 1 to infinity. How many numbers is that? That's an infinite number of numbers, right? So, okay, so how do we do that? Well, let's just see how it looks. Okay, so A1 is what? 3 over 10, right? And A2 is 3 over what? 100. So 3 over 10, that's 0.1, right? So let's see. 0.3. Okay, so this is, look, so this is 3 over 10. Plus 3 over 100, 3 over 1,000, 3 over 10,000, and it keeps going forever. All right, so how am I going to add up these infinite number of numbers? Well, let's see what it looks like. This is 0.3, 0.03, 0.003, 0.0003. Right? Adding them all up, these, it's 0.3333, and we know it's going to continue. But what exact value gives you that? What gives you, the repeating is not a thing. We're past middle school. What rational? 1 over 3. This is 1 over 3. Okay? All right, one more. So all this was just preliminary stuff. None of this is really it. Example 8 is part of the it, right? Now it says to write this series in sigma notation, okay? And the lower bound is given. So this is the lower bound. So what I want is sigma. I'm going to go from n equals 1 to something. I need to know how far to go, and I need to know what that is, that function, that formula. This is going to be a formula that defines each term in the sequence. That means, you see that series there? I need to figure out a way to relate each of those terms to its respective n. So take a look at this one. This is a sub 1, right? So n is equal to 1 here, is that right?
Yeah.
This one, n equals 2, n equals 3, n equals 4, 5, 6, 7. This is n equals 8. So that means I'm going from 1 to 8. And now I need a relationship this way. What do you do to this value of n to get negative 2? Because whatever you do to that value of n, if you do it to this one, you should get 0. If you do it to this one, you should get 5. Huh? I'm just counting. If that's the first term, n equals 1. Second term, n equals 2. Third term, and you know, a couple of you have already seen that that relationship is n minus 3, right? So then it's sigma n equals 1 to 8 of n minus 3. Okay, hang on. Super important. Parenthesis matters. Okay? So parentheses matter. If I do sigma n minus 3, that could mean that you do that, whatever answer you get, minus 3. So parentheses matter. Yes? Okay, so this is due tomorrow. And I'll see you guys tomorrow.